Hey, thank you for continuing to subscribe to Refrigeration Mentor's video newsletter. I hope you had a chance to check out that free compressor troubleshooting guide I talked about a couple times. And I hope you had a chance to check out that deep dive on overheating, compressor overheating. So it's so important to figure out why compressors have issues, why they fail, and what to do to prevent them from failing again or having issues down the road. We're going to talk about flooded starts now. What causes flooded starts and how to prevent it from happening down the road. As I mentioned in the overheat section, you need to inspect the compressors. If you're not inspecting the compressors, how do you know what caused them to have the issues? Flooded starts is caused by refrigerant traveling through the system as a gas or as a vapor, making its way inside to the compressor, and it absorbs into oil or stratifies into oil, as you can see in this picture back here. Anytime that system is off and there's an opportunity for that gas to make it back to the compressor and that compressor starts up, that is considered a flooded start. You'll see in this picture here that I have an accumulator. And some people say, well, I have an accumulator that protects against liquid. Well, it protects against liquid floodback, which we'll talk about in a little bit. But with flooded starts, it does not protect against that. As you can see, if you have a bunch of liquid refrigerant in here, that gas can travel through the tube, the U-tube, the vapor travel back, and then it can go right inside the compressor and stratify right under the oil or absorb into oil. So if you ever looked in a compressor and you've seen that sight glass with full, there's a really, really good chance that is liquid refrigerant in there. It could be too much oil in the system, but if that compressor is cold, for sure it's liquid refrigerant. Check that crankcase heater. Is it running? Does it even have a crankcase heater? And because anytime the compressor is off, and it's the coldest part, refrigerant wants to go there. It wants to go inside the coldest part of the system. That's the where refrigerant wants to go, the coldest part of the system. So really what happens, okay? What happens is that all that oil and refrigerants in that compressor, it's off. As you can see right here. Compressor is full of liquid refrigerant and oil, okay? And then all of a sudden that compressor starts up. There is a massive explosion of liquid refrigerant and oil. And this is bad because refrigerant is a good solvent. So it cleans the oil. Oil is supposed to be on every piece of the inside of those compressors. It doesn't matter if it's semi-hermetic, hermetic, scrolls, screws, rotary. You want oil everywhere lubricating it. Okay? And if you have a massive explosion of liquid refrigerant, what's that doing? It is washing that oil off of everything, causing metal on metal, causing overheat, and causing damage. So what does happen to a scroll? Well, this is what happens. This is inside a scroll set. This is the top one. This is the fixed, the stationary one. This is the bottom one, the orbiting one. It's under the crankshaft. The only way to tell if you had massive flooded starts or flooded starts in a scroll, you need to open it up. No different than a hermetic compressor or a semi-hermetic. You have to open it up and see those telltale signs, just like I put in those guides. So for flooded starts in a scroll, you'll see what we call scroll galling, metal on metal. It looks like circles because it is orbiting around. It doesn't do a 365, these scrolls. They just orbit around. They go back and forth, squishing the gas. They orbit. But what happens inside here, you have circles. And it looks like circles, and that's called scroll galling. And you'll see these are the flanks right here, the flanks for the scroll set, and you see massive gouges of metal out of there. That is really bad. Now you can have efficiency losses because the gas will travel through from one flank to the other or one section of compression to the other. And why this is important, you could have small flooded starts, so just minor flooded starts, and this is what it causes. So it doesn't cause the compressor to actually fail at that point, but it causes damage, losing efficiency. If you have a massive flooded start, and this is on refrigerant cooled compressors, you're going to have a slug. So when you think of you have a slug or if you have something breaking, that on refrigerant cooled compressor is from a flooded start. So a massive flooded start causes a slug in refrigerant cooled compressor. So on a semi-hermetic, you're getting broken rods, broken rings, broken pistons, broken suction valves, broken discharge valves, broken discus, whatever it is. You're getting broken pieces because the force of that liquid refrigerant and oil could be doing it too, because there's a massive amount of oil flying all over the place when there's a massive explosion. What else you would see on semi-hermetics is where the oil pump, sometimes you will not be able to pull that oil pump off, and that will be because of when you had that flooded starts, that refrigerant get inside the oil pump and wash it away, because the oil pump should have the oil all the time. It's the first place oil is going to hit. The main bearing to the housing of the semi-hermetic is going to be the last place. So if that is seized on there, it only could be two things. It could be from a flooded start and the oil, the refrigerant washed oil away, or contamination, like you got a piece of copper or a piece of metal in there and you couldn't open it up. So it's very, very important to look inside these compressors to figure out, was it a flooded start, or was it a slug due to a flooded start, or was it something else, overheated, flood back, contamination? This is important to tell these differences. I've been at a site before where I had an amp clamp. I put the amp clamp on because the contractor didn't know what was going on, and I watched it. And what was happening, the amps were jumping from 16 to 18 to 15 to 18 to 20 to 18 to 10 to 20 to 18 to 19 to 10 to 30, and it tripped the breaker. Well, what caused that was two things. That situation was from flood back, but also a flooded starts, because you have these metal on metal here, and that was affecting it, we believe, or I believe. And from that, if you didn't cut open the compressor, especially hermetic ones, you would know what caused that failure. So that's why it's vitally important to look inside these compressors. If it's a hermetic one, same thing. You want to look inside those compressors if you don't know what caused it. How to prevent it. How to prevent flooded starts. This is very, very important. The things you need to look for. Well, if you do not have a crankcase heater, install one. Make sure you install it in the right location. I've seen them on many, many scrolls installed in the wrong location. They don't put the screw down the seam, which is very important. They put it too low where it's not heating the oil up properly, or put it too high where it overheats the compressor. So you need to put it in the right location. But if it doesn't have a crankcase heater, add one. And in the manuals for those compressors, is going to say, depending on how much refrigerant's in that system, you may need to add a crankcase heater, or you could have flooded start situations. That's why it's important to check the manuals of the compressors. Also, set up a pump down scenario. So really what that means is that you're going to add something like a solenoid inside here. And when you pump it down, it's going to close that liquid line solenoid, and it's going to keep all the liquid refrigerant in the liquid line, if you have a receiver in there, in the condenser. So it all stays in the high side. So it pumps everything out of the evaporator, everything out of the suction line, everything out of that low side. So you do not have any of that migration from the evaporator to that compressor. But you still need to be aware, because on the high side, it still can travel from your condenser, your receiver, back into your compressor, into the head of your compressor, into the head of your scroll. So you may need to add a discharge check valve depending on the compressor itself, how much refrigerant's in that system. And if you don't, you could have an issue with liquid getting in on top of the head of the compressor. Yes, in scrolls, there is a check valve right at the discharge point, a spring-loaded one, but that doesn't, it's not 100% shut off. So just be aware that you may need to add a discharge check valve to that scroll compressor, or that compressor in general. So you need to read that compressor guide. Okay, another thing, set up a bump start. Well, so what is a bump start, Trevor? Well, that is actually where you'll start the compressor up for 2 seconds and shut it down for 5 or 6 or 10 seconds. And what happens there is, instead of exploding everything all at once, it kind of boils a lot of it off. So instead of having that full amount here, it'll boil off some of it in 2 seconds, and then off for 5 seconds. Then it'll do again, and it'll boil off some more, instead of getting that massive explosion to cause that slug, because that's what you're trying to do with a bump start, is to reduce those slug situations. Once again, Flood back is still bad, even minor ones, because you start to get this wear on wear, metal on metal, and what could happen is that metal falls down into the stator and you get a short. And we've talked about this last time. A lot of times you're going out there and you're ohming out those compressors and you're getting electrical failures, you're getting burnouts. But 80% of the time, that is caused by a mechanical issue. And that mechanical issue is causing the electrical failure. Okay, so check out bump start. There's controllers with bump starts on it, or you can do it yourself. Start the compressor for 2 seconds and shut it down for 5 seconds to really get out any refrigerant in that compressor. What you can do, if you look at a sight glass and that sight glass is full, I highly recommend doing that. Or you turn on a crankcase heater and you let it run for, 6, 7, 10, most manufacturers say 24 hours to get any of the refrigerant out, but you can do a bump start scenario. Okay, another one that I didn't really know about, refrigerant's chemically attracted to oil. So it's always refrigerant always want to go to oil, and the compressor has the most amount of oil, so it always want to be going to the compressor. So in different manufacturer guides, it's going to tell you a different type of refrigerant to oil ratio. Because if you have a lot of refrigerant in that system, you may need to adjust the oil to refrigerant ratio. This is where you go into that manufacturer guide, and it'll talk about this, because once again, refrigerant's chemically attracted to oil. So be aware of that. Check out those guides. Another thing is maybe you need to relocate that compressor to a warmer ambient or a warmer location. I've seen it where people have the crankcase heater immersion in the semi-hermetic, plus they have a blanket on it. I've seen it where scrolls have been wrapped all the way around with heat tape, and to keep it from getting too cold, because they're in such cold locations. So it'll turn on, keep it warmer inside there, so that refrigerant doesn't go inside that compressor. Also, there's a guide that I'm going to attach to this. This is the AE 221182. This is from Emerson. This is their controlling liquid refrigerant and refrigeration and air conditioning systems. This is a must read. I've read it dozens of times and I still learn things from it. I'm talking about flood back, talking about flooded starts, talking about slugging. It's not the newest manual or bulletin, but there's so much great information in there. So once again, flooded starts is caused by refrigerant migration. That refrigerant migrates into the compressor. That compressor starts up and has an explosion of liquid refrigerant, washes oil away to cause seized compressor, broken parts like pistons and rods or scroll sets themselves. Things to prevent it: adding a crankcase heater, checking they're in the right location, checking if they're even working or they're the right wattages. Having a pump down scenario, setting it up properly, setting that low pressure control up correctly, making sure that if you need a discharge check valve in the discharge line, that you add that one or have that one there. Accumulators do not protect against flooded starts. Okay, if you need to add a bump start, or if you see that the compressor's cold and the sight glass is full, you might want to do a bump start scenario. 2 seconds on, 5 seconds, 6 seconds off, 2 seconds on, 5 seconds off, 2 seconds on, 5 seconds off. Do that 3 times and see where your oil level is, because it'll be foaming in your sight glass if that's full of refrigerant. And if you have to, relocate that compressors. So I hope you learned a thing or two about flooded starts. Once again, you need to look inside these compressors to figure out what causes the failures. I'm going to put another link to my sign-up form. If you have other friends that you think this would be good content for them, they should sign up for this video newsletter, please do that. Okay, I will see you at the next deep talk, and we're going to be talking about flood back. Awesome. I'll see you soon.